Hello everyone, today we are going to be simplifying radicals, okay? And one type of radical that you may have seen before is a square root, and that's what we'll be focusing on in this class, okay? But square roots are not the only type of radical. Sometimes you'll see cube roots, fourth roots, fifth roots, and so on. And that's why we see this number right here, okay? So anytime you see this symbol right here, that means that you have a radical. Okay, so we call that radical, the symbol, the radical symbol, okay? This number right here is the index. If there's not a number there, we assume it's a 2. This number on the inside is the radicand. You're going to see that word throughout this unit. This whole thing together is called the radical. And what you need to know today is that a radical expression is fully simplified if there are no perfect square factors of the radicand, okay? So that's basically what we're going to be doing. We're going to be simplifying radicals. So steps for simplifying radicals. What we're going to do is we're going to find the prime factorization of the radicand. And that just means we're going to take the radicand, that number inside, and we're going to break it apart, okay? You'll see what I mean in a minute if you don't know what prime factorization is. Then we're going to move each group of numbers from the inside to the outside. Okay, so each group of 2 that I can make, I am going to move those to the outside. You'll see that in a second as well. And then we're going to simplify the inside and outside. And then our radical is fully simplified. So let's check out an example of that, okay? So I want to break this number apart until there are no more factors, basically. So I'm going to start by dividing this thing by 2. And that gives me 2 and 10. Okay, so 2 is a prime number, but 10 is not. I need to break that apart. I can divide that by 2. And that gives me 2 and 5. Okay, so my prime factorization of 20 is 2 times 5. Okay, so now what I'm going to do is I'm looking for pairs of numbers. Okay, and I have a pair of 2s. Okay, so each pair is going to go on the outside of the radical. Okay, everything that did not pair up, so this 5 that we have right here, it does not have a partner, it will stay inside of the radical. And that's it. This thing is fully simplified. 2 root 5 is the simplest form of that radical. Okay, let's look at another one. Okay, so square root of 90. I'm going to start by dividing by 2, so that gives me 2 and 45. Okay, I can't divide 45 by 2, but I can divide it by 3. And that's 3 and 15. 15 can be divided by 3, that's 3 and 5. Okay, so now we have these prime factors, 2, 3, 3, and 5, okay? And I can make a pair of 3s. So that means that 3 is going to be on the outside of the radical, okay? On the inside of the radical, I'm going to have a 2 and a 5. So I have 2 times 5, okay? And we're just going to multiply those together. So our answer here is going to be 3 square root of 10. So that is the simplest form of this radical. Okay, here's another one. So we're going to start again by dividing by 2. So 2 and 56. 56 can break down as 2 and 28. 28 can break down as 2 and 14. And then that can break down as 2 and 7. Okay, so I have all of these numbers. These are my prime factors of 112. So I have 2 different pairs of 2s. Okay, so that means on the outside of the radical, I'm going to have 2 times 2. This 7 right here does not have a partner, so it has to stay on the inside of the radical. Okay, so these 2, since they're on the outside, they're going to get multiplied together. That's going to be 4. 7 is stuck on the inside. So square root of 7. That's it. That's our simplest form. Here's another one. We want to break apart root 32. 2 is actually already on the outside, and that 2 is actually going to stay on the outside of this thing. So if I break this apart, I have 2 and 16, 2 and 8, 2 and 4, and 2 and 2. Okay, so I have this pair of 2's and this pair of 2's. Okay, so for each of those, a 2 is going to come out of the radical. And we actually already had this 2 on the outside, so that 2 is going to be here as well. Okay, but this 2 right here, it does not have a partner. Okay, so it has to stay on the inside. So all we're going to do is we're going to multiply 2 times 2 times 2. That's going to be 8. Root 2 is going to stay inside. Same idea on this one. We want to break apart the 20. So that's going to be 2 times 10 and 2 times 5. Okay, so these are my prime factors of 20. I have a pair of 2's and this negative 3 that was already on the outside. So negative 3 times 2 are my outside. This 5 right here does not have a partner, so it stays inside. Okay, so we end up with negative 6 root 5. Okay, one last example. We've got a big number here, but it's going to break down pretty fast, and you'll see here. So 392, if I divide that by 2, it's going to give me 196. So I have 2 and 196. That can still be divided by 2. That's going to be 2 and 98. 98 can be divided by 2. That's going to be 2 and 49. And 49 is actually going to be divided by 7. Okay, so I have a pair of 2's and a pair of 7's, and this 2 was already on the outside. So on the outside of the radical, we're going to have 2 times 2 times 7. On the inside, we're just going to have this 2 right here. So if I multiply 2 times 2 is 4, 4 times 7, that's going to be 28 on the outside, root 2. So that is our simplest form of this one. Okay. And sometimes we'll see square roots that are being squared, okay? And these are actually very easy, okay? So if you notice here on this first one, how many 2's do I have? I have a pair of 2's. Since I have a pair of 2's, this is going to be 2. The second one, I have a pair of 7's. Since I have a pair of 7's, this is 7. This next one, I have a pair of 10's. Since there are 2 10's, that's just 10. And then root 13, whenever I square something, that means I have the same thing twice. So that's really root 13 times root 13, which also is going to be 13. Okay, so whenever you see a square root that is being multiplied by itself, that number is just going to come out. Another shortcut that we're going to be able to use if we ever see perfect squares, and all of these things are perfect squares, these numbers that we have here, 1, 4, 9, 16, so on, okay? If I ever see a perfect square, I know that that perfect square is going to come out cleanly, okay? So it's going to be helpful if you know your list of perfect squares. And if you just know that, hey, anytime I see square root of 25, that really is 5. Or anytime I see square root of 144, that really is 12, okay? So we've seen some of these throughout this. We saw square root of 49 a minute ago. If we could have taken a shortcut and just pulled that 7 out. We'll do a little bit more of that in the next lesson, but just keep these numbers in mind, okay? So whenever you see a perfect square, you can pull that number out, okay? So please go check out the lesson on Canvas for today. Let me know if you have any questions. Have a great day.